You might have noticed in the animation that we just saw that we got a total solar eclipse when the new moon blocked the sun. Here it is again. And now the sun has emerged from the other side. Now, if the moon reflects the light of the sun, then in theory, it might be possible for something to come in between the moon and the sun and block the sunlight from falling on the moon. In fact, when the sun and the moon are on opposite sides of the earth, as with the case of the full moon, then it's possible that the earth itself might block the sunlight from falling on the moon. Would we notice such an event? Well, if you're observing the moon at that time, we would, because the earth would then cast a shadow on the moon. That is in fact what happens in a lunar eclipse. The sun and the moon line up on opposite sides of the earth, so the people on earth who are observing the moon will see a full moon before the eclipse starts. And then, as the moon enters the earth's shadow, the bright portion of it will start to shrink. When the moon fully enters the earth's shadow, it will be dark. And then, when the moon slowly starts coming out of the earth's shadow, then it starts gradually appearing illuminated again until we get a full moon again. This explanation of a lunar eclipse is attributed to Anaxagoras. Yes, the same Anaxagoras who also argued that the earth is flat and that the moon reflects the light of the sun. For Anaxagoras, it's the flat earth which is casting the shadow on the moon when the sun and the moon are on opposite sides of the earth. So the shadow that you saw in the lunar eclipse, according to Anaxagoras, that shadow is cast by the flat earth on the moon.